Hi everyone, welcome to this webinar this afternoon with the CNES challenges. So there was a webinar this morning. I don't know if you attended this webinar, and there's a webinar right now because there are quite a lot of CNES challenges to present. So I have with me Mr. Walter Dieudonné, who's the president of OurTime, and it's a company who works in various domains linked to aeronautics and aerospace. And Walter has been working with CNES on their challenges for this 2022 edition of ActInSpace. So this morning, Walter presented 7 of the challenges of the CNES. And this afternoon, he will present 8 more challenges from CNES. If you didn't attend this morning edition, this morning webinar, you will have access in a few days. We will put the link on the ActInSpace website to the video of the webinar so that you can check all the details that he gave about those first 7 challenges. So I will leave the ground to Walter, and first, I'm welcoming you all today, and hope you will have a lot of details. And if you have some questions, also you can ask them on the device, and I will ask Walter at the end of the presentation. Okay. So first of all, introduce Walter Dieudonné.
Thank you, Michael, and welcome back, everyone. This morning we had quite a nice presentation with 7 challenges, and now I'm going to present 8 new ones. They're quite exciting, and I was really glad this morning to see that there were some real interest in the questions, and really good questions as well. So let's start right now, and we introduce first a small video and just to see the titles, and then we're gonna go through them. All right, so we can start now. We start with the first challenge of the afternoon, and it's called Build the 3D Universe. The idea is to use a collection of geo-referenced contributions to reconstruct dynamic 3D scenes. The contributions, they can be, for example, people taking pictures with their smartphone, can come from a swarm of drones, for example, or come from security cameras. The data, then comes from different viewpoints. So you have different viewing angles. Of course, you can extend it to 4D if you add the time dimension. This is quite a challenging theme because you have it requires a lot of really good skills in the image treatment. There is a lot of work to do in image processing. Of course, you can extend this to videos as well. So again, here the idea is to take pictures from many different sources, collect them, and rebuild something 3D out of it. The next challenge is called Add a Pinch of Reality to Your Photos. In this challenge, CNES proposes to enhance existing photos in a database with photorealistic rendering using real on-location data. For example, you can use the time of the day. If a picture is taken during the day, you can make changes to the picture to make it look like it was taken during the night. You can take information from the weather. If the picture was taken during summertime, you can change the photo to add some snow, for example. You can add information about the traffic or anything really. This has a large application field, for example, for navigation systems. And the newly created photos that the system generates can be fed back into the database. Applications are quite wide. For example, you can visualize a house you want to buy at different seasons. So if you have a picture of a house during summertime and you want to see how it would look like during wintertime, you could use this system. This could be actually quite useful as well if you want to have a pretty accurate vision of the place you want to go to. If you're living in the morning and you know that you're arriving at night, you can use this system to change the photo, and you can even couple the system with weather forecasting to take into account, for example, rain. So this challenge has some pretty good economical applications. The next challenge is keep your drones on a leash. So again, this challenge I think is really interesting. This deals with the world of drones, and it has many fields of applications, both on Earth and for space exploration. Basically, the idea is to add a cable to the drone so that you can transfer energy, you can transfer data, or the cable can also be used to recover the drone if something goes wrong. Obviously, the key element will be to take into account the cable linear mass, and it has to be as low as possible, because the longer the leash and the heavier it's going to be. The idea here is to have a carrier system. Your carrier system can be a rover, for example, a mobile rover. It can be a fixed station, and this rover or this fixed station will feed the drone, okay, with energy, for example, and you can use solar energy, solar panels on your drone to feed energy to your drone. You can also get the drone sensor data in real time, and you can use your rover or your station to store the data, and you can even use this to relay the data with an onboard communication or a ground communication system rather. So basically what you're doing is you're using the drone sensor remotely, and you're using your fixed station or your rover to do all the heavy work. This really has a lot of potential for many applications, either on Earth or for space exploration. For example, for Mars exploration, this has really a lot of applications. The next challenge is called, where is my rocket? Tracking rockets usually is done with radars and onboard GNSS. This requires some serious resources. What CNES is proposing is to use a simple radio frequency onboard system with message timestamping, and with this technology you can geolocalize a vehicle location and its speed. So you can use this system to localize a rocket, a plane, a drone, a car, any vehicle really. This is a very cheap method to use, and this is using quite simple hardware, both on board for the radio frequency emitter and on the ground for the treatment, for the data treatment. Again, the field of application is really pretty tremendous. For example, for a drone, you can localize a drone using georeference buoy, for example. So think of exploration on a remote planet. If you have georeferenced fixed stations, then you can quite simply localize a flying drone. You can simply localize a rover simply with radio frequency messaging. So I think that this has really good potential in the field of exploration. Now we turn on to the next challenge, and it is called Lost Underground, Turn on the Lights. This challenge is based on the VLC technology. VLC stands for Visible Light Communication. The idea here is to use a network of emitters that can communicate with a central clock using VLC transmitters. And those transmitters, they provide a GNSS-like signal. This technology shares many commonality with GNSS positioning. This method can be useful, especially where satellite positioning is not possible. For example, underground or in warehouses, where the GNSS signals, they're quite poor, and therefore your accuracy is going to be degraded. Again, this method is quite interesting because simply based on visible light, you can localize objects, and you don't require any radio frequency signals. The next challenge is called Take Cover, Incoming Gravitational Waves. The Earth orbit is filled with thousands of satellites. We have constellations, we have really thousands, literally. We have mentioned this many times today, and we also mentioned the issue of space being really crowded now. But using all these satellites, we can use a technique called radio occultation. And with radio occultation measurements in the GNSS signals from satellites to Earth and in between satellites, so in satellite interlinks, it's possible to track in real time atmospheric and ionospheric perturbations. This is quite important because these perturbations, they are due to electromagnetic waves. And if you follow these perturbations in real time, what you can do is you can predict minutes or even hours events such as earthquakes and tsunamis. So you can clearly see the interest of this technology in places that are exposed to tsunamis and earthquakes, for example, and this could really save thousands of lives. I'm pretty sure that it's not going to be a problem to find some good ground for an economical business and a successful business. We turn to the next challenge now, and it's called Get Ready Against Infectious Diseases. This is a challenging proposal. Here, basically, you can take satellite images, you can couple these with population density, and then you need to define several relationship functions to anticipate how a disease will spread. So this is a very generic method, and you can pretty much apply it to any infectious disease. So these diseases, they can be airborne, waterborne, they can be vectors, such as mosquitoes, they can be linked to pollution as well. The complexity here is in the relationship functions, and they need to take into account as many inputs as possible to be accurate. You can really think of establishing forecast maps with a time evolution of a disease. So here again, you can see this challenge as a life-saving challenge because diseases like malaria, due to mosquitoes, they really takes thousands of lives every year. Finally, we turn to the last challenge, and it's called Jack-in-the-Box Spontaneous Structure Deployment. This challenge proposed by CNES is based on a set of articulated panels that are made of carbon fiber and epoxy resin. The idea here is to use elastic deformation and curvature, and the non-planar panels, the panels that are non-planar at rest, they can deploy. This provides a simple and reliable, robust structure, which is lightweight and compact. This can be interesting for deployable structures, for example, masts, solar panels. And again, you don't need any active electrical system. The fields of application can be for building a moon-based infrastructure, for example. It can be used on satellites for deploying solar panels. and it can even be used on Earth for building emergency shelters. So this technique basically only rests on elastic energy, and it's simple yet very robust. All right, so I think we are done now with the 8 challenges for this afternoon. So now I will be very glad to answer any questions you may have. I know that there is one question for the drones, but again, we can take the questions now.
So the questions have been asked by the same person, I think, relating to the "Where is my rocket" challenge. I'll let you read the questions here. They're all related.
Okay. Okay. The first question for "Where is my rocket" challenge. Maybe you can.
Yeah.
Okay. First question deals with is the challenge, or does the challenge require an algorithm? Well, no, because all this work has been done by the CNES engineers. So basically, the idea here is we propose the means of using this challenge. So you have an onboard radio frequency system that emits some data. This data is analyzed on the ground using some complex algorithms, and with these algorithms you can, because the messages are time stamped, you can actually localize an object. So it can be really anything. It can be a rocket, it can be a drone, a plane, a car, it can be really anything.
Same person, yes.
Okay. Okay. This algorithm can let us know where is the rocket and how to track. Yes, indeed. With this algorithm, you can actually know where it's basically, it's gonna track the object for you.
Okay. Next question from Thomas: Is there a power handling requirement for the cable of the drone? Oh, so on the drone, I can't remember this one, I suppose.
Keep your drone on a leash. Okay, is there a power handling requirement? Okay, so I mean, yes. The idea is that what CNES is offering is really the complete setup, really, especially the winch system. So the winch system, which is going to be installed on the rover, on the mobile rover, or on a fixed station. So it has to be powered, and the cable is, because you know that one of the main problem of drones really is powering the drone and keeping the drone alift as long as possible. So the idea here is that you can use the rover. So you can use either the rover power, or you can even set up some solar panels or any source of powering, and then you can feed the drone through the cable. So I mean, this for Mars exploration, for example, this could be really useful, because if you have a storm, for example, a dust storm or whatever, you know that your drones, they may drift away and you may lose it. With this system, you also guarantees that you're gonna recover your drone. So this has really a lot of different interesting points. On Earth as well, you can think of a drone with a really long surveillance time, for example. So this has a lot of applications on Earth. There is really I think there is a really good market there, and there is a lot of a really nice business to develop.
Okay, next question. Can you go through challenge number 15? Adopt a space debris again, please. So let me just.
Okay, so I think
which one was it?
It was the first one, I think.
It was not 15. Oh, that was before, no?
Well, the first one of the morning, I think it was.
That was. We've got a little bit of time.
No, it was second one. Space debris.
This one.
No, this one. Okay, we go.
Okay, so we have a little bit of time, so we are explaining again. Normally, it's on the first webinar. So Walter will go through this, but only this one, maybe to concentrate more on the 8 last challenges of the CNES. If you want to have more details on the first 7, you will have to wait for us to put the link to the video for this morning.
Yeah, I agree. I agree with you, Michael, because I think we talked about it quite extensively actually this morning for the space debris. Well, I invite you, Mr. I invite you to, as soon as it's online, to look up and to listen again to this Adopt a Space Debris Challenge this morning. Because I don't think I can. I'm going only to repeat myself with this. Again, have a look at what we said this morning. Look at the short presentation that you can see on your screen right now, and that's pretty much it, I guess.
Okay, so yes, we will put the links. Just a message to all of you. I said it, I think, at the beginning, but we will put the links to those webinars, the one that we had specifically this morning with Walter, and this one this afternoon for the CNES challenges, very soon on the website. So check it to have a detailed description of each of those challenges. Yes. Okay, so we'll go back to the 8 last ones. I hope this one is about one of them. Hello, can we have more information about CNES 14 invent public services for space? This was also this morning.
Yeah, it was this morning. Just a quick word on this because we did not talk much about it.
Which one was it?
Find it. Invent public services for space.
Ah, that's one.
Okay. Well, the idea here is it's all about sharing. Really, it's all about sharing. You know that on Earth, what you can do is instead of storing all your data locally, you can store it on the cloud. And why not having a cloud in space? For example, for data storage. Again, instead of having onboard all the memory and all the requirements, then you can simply have data links, and you send the data back to the whatever space station is up there, and this is really about space cloud. You can also think of this space station or whatever to be a central hub for powering satellites, powering using lasers, powering using or even for refueling, or even for changing batteries, just like stop and go. Satellites comes, docks, and you take out battery and you put a new one, so you extend your satellite. So really, there is, again, it would be a common place where satellites, they can stop, they can change a sensor that is not functioning properly, they can upgrade a sensor, they can upgrade a memory or a CPU. Basically, it's really a central place, a central station that will be the place that you actually feed with new equipments, for example, and then your satellites, they will come, they will get service, and then they will leave. I think that this would be really useful, and this probably is going to be the future of space travel as well, because this pretty much you can extend your satellite life really a lot. But again, as we said this morning, there is something quite important, is think of satellites or whatever is in space, think of it as serviceable. So you have to design it keeping in mind that it must be easy to replace batteries, for example. So like plug and play. It must be easy to have add-ons. So to add an extra CPU, for example, whatever, or to add an extra sensor. So a satellite could really pretty much be evolutive. So it can really be upgradable, and therefore you can keep up your satellite, knowing that this is putting a satellite in orbit is really what costs the most. So I think that there is the public services for space, they don't really exist right now. And I think there is, well, it's a long term, but I think there is really something to do there. And one last point is nowadays we go towards constellation. We have thousands of identical satellites that are flying. So if you think of this, then it's, if they are standard and if there are thousands of them, then it would be easy to service all of them. Now this also maybe call for standardization. Think of maybe it would be nice to share some common requirements between different platforms. So maybe power, maybe CPU or data storage, or even different modules. So having commonality between space platforms would be actually something you should explore. Okay.
Okay, next question. How many challenges must we do as one group? One is probably enough. I advise you, yes, to, you have one challenge, and as a team, one day is a hell of a work. So yes, just concentrate on finding the right one. You can already look at all of them on the website, so you can find the one that suits you the best and suits your team as well. So if you haven't found the team yet, maybe have a few challenges in mind, and then ask the future members of your team what suits them best as well, because you will have to work probably in different fields, business, technical, to make the project work, and to eventually maybe win your edition of ActInSpace. Okay. Well, this question is no need, the person has left, and it's about this morning's presentation. My question is about challenge number 7. Do we need to consider the space or Earth environment? So I don't know if it's challenge number 7 from this morning, or if it's called CNES 7 on the website. You think?
I'm not so sure. I guess challenge 7. Challenge 7 in this morning edition was called the helicraft carrier. So, well, helicraft carrier. The question is about do we consider space as well as Earth, right?
Yeah,
I don't see the end.
Yeah, that's the one.
Okay. Okay, space and or Earth. Well, sure. I mean, you said and or, yeah. You can either think of. I mean, the idea is if you come up with a really strong technical and economical setup, and you say using this this idea from CNES that we have these rotary aircraft with no fuselage, and we can really do something really great on Earth only, then sure, I'm sure you have all your chances. If well, in space, obviously this has absolutely no interest. But for space exploration on a planet with an atmosphere, so on Mars, for example, we did not really think of it when it was actually developed. It was really an Earth-based idea. But you could think of a drone, for example, that could, I mean, you could really think of a drone for Mars exploration that could be based on this idea of having just a blade that rotates, and within the blade, inside of the blades, you have your power, you have your avionics, and all this. So yeah, why not? Why not?
Okay, there was one last question from I don't know, that's not a name, it's a number, but about the where's my rocket. I think it's the same person as before, wanted some precisions. You want electric board and some equipment to explain how to track the location related?
No. The technology of tracking is already there. CNES provides it's basically a set of what you have, an onboard radio frequency emitter that is on your drone or on your plane, whatever, and you need a receiver on the ground. Okay, so this is using standard radio frequency systems, and CNES provides the algorithm that runs on a standard PC. And with this algorithm, provides the algorithm that will give you the location.
Well, those ones that person has left. Still about the same from someone else, from Marvin. A question still about where's my rocket? Is the system mainly designed for near-Earth application, or is it supposed to be used in deep space and on other planets where there is no GNSS or other tracking mechanisms?
Okay, Marvin, this is a really good question, actually. Originally, this system was developed for Earth applications. So typically to track moving vehicles or moving flying vehicles. This was the original idea. But as you mentioned, for space exploration, this has a really great potential. Think of a moon base, not even go to Mars. Think of a moon base. If you want to locate your rovers, if you want to locate whatever is coming up and landing, or whatever is lifting off, you don't have any means of locating these items using standard GNSS. So this is especially, I would say, this is especially well suited and useful for space exploration, because you can track, a moving rover, you can track a drone on Mars, but you can also even track a person. If attached to this person, you have a small radio frequency emitter. So this is, I think this is especially useful for space explorations where GNSS signals are not available. But again, back on Earth, this is for drones. This would be useful as well.
Hello, in challenge CNES number 4, I don't know which one it relates to, we should design new suitable drone for flying in the space, or it should be suitable for the Earth?
Okay, I don't know which one it is, number 4. Let me check. Okay, it's number 4 this afternoon then, huh?
Probably.
Okay, yeah, I mean the design is yeah. Where's my rocket? Yeah. Well, it's really up to it's up to you to design the drone. There is again, I guess you're referring to this where's my rocket challenge. Here the technology provided is simply the RF technology and the algorithms laying behind it. So it's, I mean, it's up to you to design the drones.
Okay, so I think that was the same person with the numbers here. I don't know, challenge number 8. I don't know what that
Challenge number
to.
8, so it's the last one of the day. Okay. Can you explain more on challenge number 8? So it's the last one. It was called Jack in the Box. Okay. The idea, it's basically you use panels. They're made of carbon fiber, these panels, and epoxy resin, and they are curved. All right. So you use this curvature, and you use these elastic energy stored in this curvature. Simply, it's really just like a jack-in-the-box image. You see, whenever you release it, so the panels, they will be strapped to make sure they folded together, and the panels are linked one another with some wireframe. It can be a Kevlar wireframe, for example. So when you unleash, or when you break up the the Kevlar wireframe, the strap, then it will spontaneously, it will just deploy. So if you have, and this is really compact, that's a good point, and this is really robust as well. Plus, it's also it's a passive system, so you know that if you break the strap, if you cut it, then you know it will deploy. So one problem with this is the deployment kinematics is very hard to control, so it just deploys. That's all. So the idea is physically the panels, they want to get flat, so they want to lose their curvature energy. So that's pretty much it. So this can be really useful for space exploration, because you can have infrastructure in space. So for satellite, for example, you could deploy a mast, you could deploy solar panels. For moon base, you could deploy a structure, a shelter, for example, but you could also deploy shelters back on Earth if you have some crisis.
Okay, next questions from Rama. Where could I find the recorded videos? They are not on yet. They will be. You will have the link very soon. Check every day the ActInSpace website. They will not be on tomorrow, but in the coming days, there will be one by one arriving. So you will have the links to the videos of the different webinars. Okay. Is it question from Azil? Is it possible to get in contact with someone if we ever needed some help or further questions, and how can we check the recordings? So the recordings are already answered, but for the help during the hackathon, you will have some experts in your city. So the different cities organizing ActInSpace are supposed to find some experts to help the different participants on site. But there will also be some experts off-site, and they will be available online on the website. There will be a chat as soon as you finish registering as a team with your team members. You will have access during the hackathon, of course, not before, to some experts in different fields. So you will be able to talk to them and get some advice from them. Okay. I think it's the same person with the question, I think, about the drones, but I know it's about where's my rocket. Asking, I can write algorithm, is that okay? Where is my rocket?
Well, as I said, the basis is already given to you. So the algorithms, they are already given, but sure, there is space for writing up code and software to get along with it, for sure. Sure, I mean, you can just write codes, I guess.
About the same challenge, will you provide? It's a question from Ahmed. Will you provide the details of the radio system? Is tracking station located on Earth or space?
Okay. What you do basically is you have you send a message from the emitter that is located onto your moving vehicle. So your moving vehicle can be, as I said, it can be a rocket launching. It can be a moving car, a flying drone, and this can be on Earth. This can be on extraterrestrial planets. And this message that is emitted from the vehicle has a timestamp, and taking into account, okay, I'm not going to go into the details of phase shifting, and this is quite detailed. This is not the place to discuss it, but of Doppler and everything. But you have a tracking station. So the tracking station is located. Well, it's located. Well, if it's on Earth, then it will be located on Earth. That will be your station. If it's on the planet, that it could be your mobile vehicle, or it could be your base. And in this station, in the tracking station, then you are running the software that takes the information, the radio frequency information, and deals with it. So it takes it, and you do. It's all about real-time processing. It's quite complex. It's real-time processing, and with this, you get the information on the location. So this is quite a beautiful system actually, because you really only need a simple radio frequency emitter.
Someone is asking, Aziz, about, could you explain more about CNES number 10, gravitational waves?
Okay. So the gravitational waves, it's the last one, take over, yeah. Gravitational waves. Well, the idea here is whenever you have, for example, if you take earthquakes, because before they happen, you have some perturbations that are propagated. So you have what we call the gravitational waves that are propagating. These waves, they are going to perturb. They're going to these waves created by the ongoing earthquake, because before an earthquake really actually takes place, it's you have a lot of motion taking place before, micro motion, but you have a lot of micro motion taking place before. These perturbations, they propagate in the atmosphere, so in the lower layers as well as the upper layers up to the ionosphere, and this propagation actually it perturbs GNSS signals, and it perturbs in general signals. And this perturbation is what you want to look at, is what you want to record. And because you have so many satellites up in space, talking back to Earth, so all these constellations, you have you have a lot of satellites talking to each other actually. And with this, if you analyze the signals, if you know what to look for, and this is really the core of this challenge, is to help you and to tell you what to look for. So the technology is basically here. They tell you what to look for and how to find it. Well, you will find all these hints that something big is going to take place. So that's why this can be an early warning system, or an early alert system, so that you can detect that something is going to happen. And this something, an earthquake, for example, could be generating tsunamis. So this is not an easy task, because you need to do all this real time. You have a lot of data to acquire. You have to quickly process the data. So this is not an easy task, but this has a real economical interest, because again you're looking at saving thousands of lives.
Thank you, Walter. Another question. It was mentioned that the algorithms will be given to us. Can you explain it a little bit more, please? And what else will be given to us?
Okay. Well, we're not going to give you the actual lines of codes, because I don't think you will get it eventually, for sure. But I don't think this is really the point of going into so much details for this first phase of your work. You should start from the principle that you have the data. So, for example, start from the principle that you have the location. Start from the principle that, I mean, you have the location for this Where's My Rocket. Start from the principle that you have the early warning that an earthquake is going to come up in the next 4 hours. So you start from this principle, and then from this, you build what comes before, and you build what comes after. And you have then you can present your technological chain, you can present your business plan, but it's really too early right now to go into the details of giving you the actual software, running it, and doing a real-time presentation. Again, you make the assumption that you have the data.
Thank you. Hugo is saying, sorry, but can we have some information about challenge number 13?
Okay.
I'll let Walter find it.
I guess it's incoming. It's the gravitational waves. So I think we talked about it just right now.
Yes, probably the question came.
Yeah.
Came 6 minutes ago, so
yeah,
probably
so
you have your answer. Okay. Concerning challenge number 5, so if it's 5 from this afternoon, it's okay. What is the nature of the data provided in relation to the climate?
Number 5. I guess actually it's related to this morning presentation for the solar panels, and I think we had this question already. I think we had this question this morning, I'm pretty sure, and we answered it. Let me check again. I guess it was about the solar panels. Right again, if it's not, but we answered this morning then.
And can it not be? Someone is asking also about challenge number 5. I don't know if it's this morning or this challenge 5 from this afternoon. I don't understand the challenge number 5. Could you precise what we must do?
Okay, challenge number 5 of this afternoon
is
lost on the ground, turn on the lights. So we go back to this one then. What you must do. Here, as for most challenges, what we do is we give you the technology, we give you the means. So here, the technology that is given to you is how to track people, vehicle data, people, vehicle, moving objects, how to track them using VLC, so the visible light communication. So this is what is given to you. Now, again, you won't have time to actually go into the detail of the technology, but as I said just earlier, you need to prepare what comes before, what comes after. You need to build something upon this technology, okay? Make the assumption that the technology is available to you. The technology has been proven to work. And from this, you can elaborate your business plan and your technological chain. So here, the idea is using this, basically data that you encode in lightning. So what you do is you actually in the light, you can modulate the light basically to insert messages, and these messages you use pretty much the same technique as GNSS. So you use time stamping, and with this, using a set of emitters. So usually you have about 4 emitters, and with this you can actually track a location. And this is quite interesting because the data rate or the bit rate that you can reach is 500 bits per second, which is not negligible. So this is quite useful because you can, if you're really deep underground, for example, you can actually locate objects. And
sorry, I think he's saying there's a misunderstanding. I speak about build the 3D universe.
But okay, so now build the
3D universe.
So the question then on the build the 3D universe. To be more precise about it, okay. when you have think of a football game. You have a football game and you have all the spectators taking pictures, and they all take the pictures from their viewpoint. The idea here is you take all this information that goes into a central database, and then with a computer software, you take all this information that comes at different angle, different time, and you do 3D rebuilding. So this can be useful for sporting events, for concerts. This can be helpful. I mean, if you have a security cameras and something happens, then you can rebuild a 3D scene. This is actually the rebuilding of 3D scenes is very important actually. When you have some industrial catastrophe or events, then you can rebuild in 3D what happened. So I guess that's it.
Someone would like to ask about the infection challenge.
Okay, about the diseases. Well, there is no real clear question, but this is the last one.
Oh, the last one.
No, the one before, sorry. Okay, so the idea here is really, it's all about the functions, the relationship functions. The idea here is to say that you can use information coming from different sources. You can use information coming from satellites, so satellite pictures. Satellite pictures, yes. You can use information from the weather. You can use information from density populations. You can use as many sources as possible, and you have to define functions. And these functions, they're really complex, and the more complex, the better. You basically take into account as many different factors as possible, and with this, you can, and this is what is provided, is how with these relationship functions you can rebuild forecasts on the propagation of diseases, because these diseases, they depend on whatever you put in your function. They depend on the weather, they depend on the density population, they will depend on the ground type, if it's a forest, if it's an ocean and a desert. And so basically this is a rather interesting domain, because you can really create, just like for weather maps, you can really create disease maps that will tell you how a disease will spread within a population, or how it will spread on a location on Earth. So the interesting point of this challenge is that it's very generic. So you can really think of pollution, for example. How will particles affect people? You can think of a vector-borne, how mosquitoes will transmit a disease. You can think of even a virus, how a virus will spread. So all of this is actually very important, I think, and there is a very large economical and business plan to build on that.
Well, that's a question, Hugo, about a challenge that was this morning. So for this, as we said earlier, most of the challenges were really detailed this morning, and there were some questions also asked by the participants. So you will have the possibility to look at the video in a few days and check exactly what you need about this. But we cannot go back on the previous challenges. Sorry. This was answered. And there's the question from Olivier: how is rebuilding 3D scenes linked to space technology, since using space tech is mandatory for an ActInSpace team?
Okay. if your question is about how this can be used or for space or in space, I think it can be really used for space. Think of cameras placed on the space station at different viewing position. Think of cameras placed on astronauts or on the moon base or whatever. Again, the idea is how to build 3D views out of 2D pictures. So pretty much this can apply to space as well as to Earth.
Okay, so I think that's the end of the questions. I don't know if you guys have some other things you want to ask Walter about the challenges that we presented this afternoon. So up, let's go back to the challenges that we presented. So there was build a 3D universe, add a pinch of reality to your photos, keep your drones on a leash, where's my rocket, lost underground, turn on the lights, take cover, incoming gravitational waves, get ready against infectious diseases, and Jack in the Box. So I think we've talked about most of them. Should we do everything during 24 hours of the hackathon, or should we prepare something before the hackathon as well? As I said earlier, you can start working. It is advised that you look at all the challenges, and if you have some team already, you can already start working. It's probably too fast to start working without the team, because maybe your team partners will tell you, okay, I'm not really interested in this challenge, and you will have to drop your work. So if you have your team, you can start working. Maybe also don't go too far on the work before the hackathon. It might be clever to start working, but not to go too deep into it, because the experts that will be there during the hackathon will maybe tell you to redirect your work in some ways to fit the challenge perfectly. So you can, okay? You have everything at your disposal. Also, I forgot to mention that on the website, you have access, and please download them, check them, study them. You have access to all the guides that we've prepared, the guides for the participants, the guides for the jury. So what is requested of you as a participant, and what is requested for the juries as well. So it's interesting for you as a participant to know what is requested of the juries. And you have the grid also that will be used to decide who's the winner of your edition. So you know what you will be requested of. It's probably not English, my sentence, but probably you understand. Walter, you want to add something?
Yeah. If you go on the website, you will find for these the challenges that we have presented today. You will pretty much find what we presented with the same themes, the category, the description, the data, the issues, and the tags. But it will be actually more detailed, especially for the data and technology. And you will have a link, and it's a very important link, because this will guide you to the actual full detailed paper, and this has usually 10 to 20 pages, and you have all the information that is detailed. This is really technical though, but in case you really identify what you want to work on, this is a gold mine to start from, and I'm sure this will answer a lot of your questions. So go on the website, get the link, and you can get a bit ahead of time for the hackathon.
Okay. Are there any other questions, everyone? We're quite on time. So as I said earlier, this session, this webinar has been recorded. And like the other webinars that we are doing, they are being done at the moment for all the different challenges. So for the moment, there's none on the website. We're doing the webinars, but then they are recorded and they will be put the links to those videos will be put on the website, and you'll be able to watch them again, or check the ones that you haven't been present to. Okay. So if everything is all right with everyone, we've got 34 people left live. So we thank you very much for attending this webinar. Thank you very much again. We hope you can start finding your team and maybe find the challenge you want to work on, and maybe start working on it. We wish you all the best for the hackathon. You can join us also for the next webinars. There's one in 2 hours. I think it's at no, in 1 hour actually. There's one at 4. I don't know if you inscribed, but check it. I wish you a very nice day. We've got a nice thank you. Thank you, Akif, and thank you, Walter, for coming today.
Thanks.
It was a lot of work because a few challenges from CNES. So thank you, everyone, and have a nice day, and see you soon. Thank you, everyone. Fawzia, Azil, Akif, thank you very much. Bye-bye.